Next speaker, our very own Chris Tucker, often described by Patrick Cozy as a longtime fanboy of Cesium. So he'll present on how OpenSensorHub combines 3D tiles with the OGC API connected system standard to integrate all sensors and sensing systems into CesiumJS. So Chris, take it away.
Thank you. Can you hear me? Awesome. Thank you. Hey, thanks for sticking around. I'm less sexy than the last guy. That was really cool. So you're going to hear a lot about the Open Geospatial Consortium. Who here has never heard of the Open Geospatial Consortium? Okay, you're going to learn something. And who here is the Chief Standards Officer of the Open Geospatial Consortium? That guy in the back of the room. So if you have real questions, go hunt that guy down. Scott Simmons, real American hero. All right, so I'm going to pound through this as fast as I can so we have Q&A. So this is probably more history lesson than technology demonstration because I'm old. So those of you, as you get older, you talk about the past because you're old and that's all you can do, and you suffer from like early onset dementia, like me. So not that long ago, time dynamic 3D was really, really, really hard. Like not that long ago, as in when I was y'all's age. Streaming observations from real-time 4D sensor systems into a common 4D framework, it was super niche. Like nobody really did it, and it was very, very hard. Projecting data streams of observations, and you're going to hear me use those terms a couple times, onto or within 3D built and natural terrain, it was kind of like magic. If somebody did it, you'd sit there like, dude, how are you doing that, right? And there were a few companies that did it, if you think about like the late 90s, or the 90s and the early 2000s. If and when it was done, right, particularly when it wasn't just one sensor type, like somebody'd have a demo of satellites and go, oh, that's cool, but like, or drones, but when you took many, many different kinds of sensors and put them into a common 4D framework, it really suffered from a lack of interoperability. It tended not to be plug and play. It was just some really smart person wired it all together, and that was cool, but it really wasn't awesome. It was deeply problematic when you saw it going on. But thank you to the Open Geospatial Consortium. If you don't know what the OGC is, it's the international technical nerd circus that governs all the geospatial standards that we all know and love, or if you don't know and love them, you need to get to know them and learn to love them. I'm one of the guys that's been around for like quarter century, so I can tell you a lot of OGC. But of course, because I'm old, I've got a timeline, right? So who here was born in 1990? Raise your hand. I mean, before 1990, right? Okay. So like all of you that weren't even born, like this, so this story, like this is actual like history lesson. And so there were actual people there doing, how do I put stuff in 4D? Like I'm not saying it didn't happen, but it was very, very niche and very, very hard. And it wasn't until a standard called SensorML, sensor model language, came out via NASA and into the OGC that this whole kind of cascading set of events happened. And we ended up with a set of standards called the OGC Sensor Web Enablement Standards. You ended up with Cesium popping up, if you know the Cesium logo, in about 2012, which made the whole 4D thing in a browser actually happen. Time dynamic 3D, what I call 4D, happen. And then I'll talk a little bit about OpenSensorHub, which is kind of a sister open source project. And I'll tell you, we used to have this thing called Spacetime Toolkit. When Cesium showed up in 2012, we had a conference call and we threw away our code. We threw away 20 years of code because now I can do it in a browser. So we just converted some of our code into JavaScript and we were good. That's the power of CesiumJS and that kind of the revolution that happened to me, and that's why I'm the original Cesium fanboy. 3D tiles came after CesiumJS, right? So that's the power of open source plus open standards. All of a sudden, I could not just put my sensors into a time dynamic, 3D environment called CesiumJS. I can now project that onto the highest resolution terrain data, and it was awesome. And most recently, even though it hasn't been announced because Scott hasn't sent the press release out, the OGC has just approved the new OGC API connected systems. I'll talk a little bit about that. So CesiumJS is way more than 3D tiles, or Cesium's way more than 3D tiles. And I know everybody loves 3D tiles. I love 3D tiles. But CesiumJS offered the first browser-based time dynamic 3D framework for integrating real-time, right, and temporally synchronized data it was a revolution when it happened, right? Because WebGL, I know the kids, WebGL's been around forever. No, it hasn't, right? There was a day it didn't exist, and then there was a day it existed, and all of us who are in the biz were like, what the hell just happened? It provided the ability, right? It provided a geodetically correct framework from space all the way to Earth. I always call it Einstein in a box, right? I mean, all the math was taken care of for you. It's kind of amazing. And 3DTiles then allowed for Earth to be characterized in such a way, right, that I could have all of my sensing data tied with precision and accuracy to the 3D data across space, air, land, sea, cyber, and electromagnetic domains. That's kind of a Department of Defense term that I've taken on for my own, right? Because we go, oh, the satellite guys, they do space. And the drone people, they do air. We have a ton of sensors on the ground. We carry them around in our pockets, right? In the oceans, they're heavily sensed. Even in the cyber domain, right? We know what's going on in cyberspace. Some people do, because there's sensors all over. And in the electromagnetic space, whether it's an RF emanation or it's a radiological sensor, right? There's so many kinds of sensors out there. So connected systems came along again, starting based on SensorML. This supersedes the OGC Sensor Web Enablement. There's a bunch of words here that there's no quiz. It's just to show you that there are words that describe it. Those links really matter. I mean, there's the OGC website. The spec is fully on GitHub because the OGC is a very open and transparent process. And if you really want to nerd out, there's a 120-page reviewer's guide that you can read. And it was written not by the nerds, but frankly, I wrote a lot of it, and I can barely spell nerd. So it's useful at the manager, program manager, kind of architect level. So I just want to give a little primer. We switched from sensor web lingo, a web of sensors, right? World Wide Web of sensors, whatever, to connected systems for a very deliberate reason. Turns out all of your sensors are made up of small s sensors, processes that do something with the observation, you know, the stimuli that come in, and then actuators. It could be as simple as like a door sensor, like are you open, are you closed, right? I'm open. Close yourself. That's an actuator, right? So there's sensors, processes, actuators. But these systems, everything, the world is filled with systems. All of these systems provide data streams of observations. Again, I said that language is going to come out. But it also enables control streams of commands. What do you mean by that, Chris? I mean, through this, you can drive a robot, task a satellite, fly a drone, unlock a door, slew a camera, invoke a process, deploy an effect. That's pretty cool. And you go, yeah, but how does that relate to geospatial? Well, all of these systems exist in space and time. By definition, right, everything on or around the planet exists in space and time. And so if I want to deploy an effect at a place and time, these standards let you do it. If I want to, you know, slew it in 6 degrees of freedom in the space and time that it is to collect more observations, these specifications allow you to do it. And when I say systems, right, we mean sensors. We mean things. We mean robots, drones, satellites, control systems, devices, and all manner of platforms. And I know the geospatial community, we tend to like take the data once it's off the system, and then we call it geospatial data. All that data is being collected by a system, even if the system is a human, right, with a GIS, right? There's lots of humans with a GIS, and they can constitute a system. Space, air, land, sea, cyber, electromagnetic, and every phenomenology. Who here knows what the word phenomenology means? You don't need to, right? It's like nerds speak for the way in which the system sees the world, right? What it senses. We use eyes, ears, skin, you know, that's how humans do it. We can't see in infrared, right? But there are sensors that can see in infrared. That is its phenomenology. And the OGC Sensor Web standards have allowed us to do this in all these phenomenologies. And it's not just for visualization. A lot of people go, oh, that's cool, that's a visualization framework. No, right? This is a framework for discovering your services, self-describing. The system's allowed to self-describe themselves. You can discover them, access them, process the data, reason on it, visualize, task, and take action. So we have kind of a sister project. It actually started, hold on, I was going to do a striptease, but the mic won't let me. But there's another project called OpenSensorHub. Started at the same time as Cesium. We're decidedly less explosive and successful as the Patrick Cozy machine, but we've been chugging along for a long time. We write drivers for various kinds of systems. Think of it as printer drivers, right? So we can let you get data streams of observations off and send control streams of commands to it. We have a persistence engine that lets you time synchronize all this data. We let you plug in third-party processing engines of various kinds and deploy them out to the edge onto a Raspberry Pi, an Arduino, an Android, we don't care, or in massive cloud implementations. And over there in the top right, typically is Cesium. But I have another slide, because not just do we have OSH, but we have OSH Connect. It's our client frameworks. It started out as a JavaScript framework that goes back when we threw out Spacetime Toolkit. We just wrote OSH-JS, now we call it OSH Connect JavaScript. And we did it so that we could drop these OGC sensor web data streams into all of those web client frameworks, Esri, Mapbox, Leaflet, OpenLayers, DeckGL, whatever, and Cesium. And Cesium's been our go-to because it provides us that 4D browser-based globe. And I'll tell you, most sensors, you want your 4D. You don't just want 2D plus time. Last year, we built a Java framework to help us plug into various Java clients. And then we built a Python framework. We're getting ready to do a QGIS plugin with that. We've already deployed it into OWS lib, which is a very well-adopted Python web mapping framework. And this, towards the end of the year, we are pushing to do an OSH Connect C++. Think of it like Cesium native, where we can plug into Unreal Engine. So we're making a run for the border. I think I'm running out of time. You got to have a demo. Oh. At a Cesium conference, you got to have something that's like visually appealing, because otherwise it's just stupid. So like this is just air domain, ground domain, and electromagnetic domain.
Huntsville Arsenal.
But right, this is obviously it's a video.
Video and drone telemetry data is extracted from MISB-compatible video stream and converted to standard OGC data streams. Platform location and orientation, as well as sensor orientation and focal length, are used to compute the view frustum.
Projecting the drone data into the common 4D space on top of your 3D tiles planet, world. As the car drives past, it's going to go down past some like radiological sensors, et cetera, et cetera. We've got a whole YouTube channel of weird stuff. It is actually short on 3D tiles. It's interesting, right? Because we've always viewed from the beginning CesiumJS as our framework, our visualization framework for time dynamic 3D. So 3D tiles is just this extra cool bonus that you get by using Cesium. If you have the 3D data there, drop it in, and then all of our sensor data projects on top of that. So I'm gonna skip to the next slide. Oh my God. So anyways, hopefully I've given you a reasonably compelling review of 3D tiles and connected systems put together. I tell you, if you're trying to bring real world systems, it could be something as simple as a Raspberry Pi with a sensor on it to your own satellite or your own drones or your global network of radiological sensors or whatever you want to do. If you want to bring them into a common 4D framework in real time, that's really what OpenSensorHub and the OGC API connected systems is there to do. So I'm done.